Hello everyone. In this video, we're going to determine the inverse of exponential function, and this is the second part. Before we go over this problem right here, let's have a review on how to change exponential form to its equivalent logarithmic form. Please remember that we can change an exponential form to its equivalent logarithmic form following the general rule right here. This base that we have here is going to go to the base of the logarithmic expression. This exponent that we have here, exponent m, will become the value of this whole expression that we have on the left. And this a that we have here will go to this part right here, which we call as the argument. This is how we change a given exponential form to its equivalent logarithmic form. Let's take this first example right here. We're supposed to determine the inverse of this function f of x is equal to 2 over 3 quantity 4 raised to the power x plus 2 plus 5. In order that we can determine the inverse for this exponential function that we have right here, there are steps that we need to follow. The first step is to replace f of x with y. So this f of x here becomes a y, so I'm just going to go ahead and rewrite this. Okay, after we're done with the first step, we're ready to move on to the second step. The second step states that we're supposed to replace every x with y and every y with x. Isolate the exponential expression on one side of the equation, convert the exponential expression to its equivalent logarithmic form, and solve for y. So part of that second step is to again change the y to x and x to y so that we can go ahead and rewrite this as okay, so I've changed the y to x and then the x to y. Part of this second step is to isolate the exponential expression. So this 4 raised to the power y plus 2 should be the leftover on this right side. But then we have a 2/3 and the 5, so that we can go ahead and subtract 5 to both sides. So minus 5 and minus 5. So that we can cross the 5 out, we are left with x minus 5 is equal to 2 over 3, parenthesis 4 raised to the power y plus 2. Our target is to isolate this 4 raised to the power y plus 2 by itself on the right side so that we have a fraction 2 over 3. In order that we can undo this fraction right here, we're supposed to multiply its reciprocal. Reciprocal means we flip this 2 over 3. So I'm going to multiply this by 3 over 2. If I multiply the right side, I will do the same thing on the left side. So multiply this by 3 over 2 as well, so that we can cross this 2 and 2. The 3 and the 3 gets crossed out. So we are going to distribute this 3 into the terms inside the parentheses. So this would come out 3 times x is 3x. And then 3 times negative 5 is negative 15. And this is over 2. And this is equal to, again, the 2/3 have already been crossed out. So we are left with 4 raised to the power y plus 2. So then that's one of the sub-steps in step 2. Now, the other part of this step is to convert this exponential expression to its equivalent logarithmic form. So this is the general rule right here. So if we are given the exponential form, the base would be the base for both the logarithmic expression and the exponential expression. So this can be rewritten as log base 4 of this value that we have right here, 3x minus 15 over 2 is equal to the exponent y plus 2. So again, part of the second step is to isolate y by itself. But then we have a 2 right here, so that we can go ahead and subtract 2 to both sides, minus 2 and minus 2, so that we can go ahead and cross out this 2 and 2 here. So we are left with log of 3x minus 15 over 2 to the base 4 minus 2 is equal to y. So then we're now ready to move on to the third step. The third step is to replace the y of the equation solved in step 2 with f negative 1 of x. So that we can go ahead and say that the inverse is f negative 1 of x is equal to log of, that's gonna be 3x minus 15 over 2 to the base 4 minus 2. So this is the inverse of this given function that we have right here. On the side, you will see the graph of both the inverse and its function. In red, you will see the function y is equals to 2 over 3, parentheses 4, to the exponent x plus 2 plus 5. And the one in blue is its inverse, which is y is equals to log of 3x minus 15 over 2 to the base 4 minus 2. You can see that both of these equations are symmetric with respect to the line of symmetry y is equal to x. Meaning if we fold this graph across the line of symmetry y is equals to x, these two graphs would match up. This means that these two equations that we have here are inverse of each other. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. There are steps that we need to follow in order that we can determine the inverse of this function right here. The first step is to replace f of x with y. So in this problem right here, I'm just going to rewrite this. This f of x will become the y. Once we've changed the f of x to y, we're ready to move on to the second step. The second step states that we're supposed to replace every x with y and every y with x. Isolate the exponential expression on one side of the equation, convert the exponential expression to its equivalent logarithmic form, and solve for y. So then we go ahead and change this y to x and this x to y. So I'm just going to rewrite this. So again, our target is to isolate this part right here so that we can go ahead and add 6 to both sides. So that would be plus 6 and plus 6 right here, so that we go ahead and cross the 6 out. We are left with x plus 6 is equal to 5 halves, and that is 1/4 raised to the power y plus 1. Again, we 1/4 raised to the power y plus 1 isolated by itself here, but we have a 5 halves here. So we're supposed to multiply this by its reciprocal so that we can undo the 5 halves. So I will multiply the right side with 2 over 5. I flip this 5 over 2 with it, I get its reciprocal. I will multiply the same thing on the other side. That would be 2 over 5, so that we can cross the 5 and 5, the 2 and the 2. So we are left with this 2/5 shall be distributed to each of the terms inside the parentheses, the x plus 6. So this would come out 2 times x is 2x, and then 2 times 6 is 12. So that's a plus 12 over 5. So that is equal to 1/4 raised to the power y plus 1. So we already have isolated the exponential expression on one side of the equation. So then we go ahead and change this to its equivalent logarithmic form. So from exponential to its equivalent logarithmic form. So that we can go ahead and say that our equation would come out . Okay, so we are supposed to isolate y by itself here, but we have a 1, so we subtract 1 from both sides minus 1 from both sides, so that we can go ahead and say that our y is actually equal to... Now we are ready, since we already have isolated the y by itself, we're ready to move on to this third step. The third step states that we're supposed to replace y, the equation solved in step 2 with f negative 1 of x. So this becomes f negative 1 of x is equal to, that's gonna be log of, that's 2x plus 12 over 5 to the base 1/4 minus 1. So there's a minus 1 right there. So this is the inverse of this expression that we have up here. On the side, you will see the Desmos version of on the side, you will see the graph of these two functions right here. The one in red is the given function 5/2 quantity 1/4 raised to the power x plus 1 minus 6. While the one in blue is its inverse, which is log of 2x plus 12 over 5 to the base 1/4 minus 1. You can see that both of these graphs are actually symmetric with respect to the line of symmetry y is equal to x, which means that if we fold this graph on this line of symmetry y is equals to x, both graphs will match up. This means that these two equations are inverse of each other. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!